Cold Dragon of the North. No, we're not talking about Captain Ron. Discovered in 1992 in Alberta, Canada, thought to be a Quetzalcoatlus, but recently research has discovered a new finding of a new genus of pterosaur. Today we have paleontologist of the University of Southern California, Dr. Michael Habib, talking with us about the discovery and how significant these findings are. Lots to discuss, so please welcome to Truth Be Told, the one and only Dr. Michael Habib. Cold Dragon of the North. No. We're back. We're actually two in studio this time.
Unbelievable. And a guest in studio. How about that? There's three in studio.
And a nice studio, too.
Oh, thank you, sir. Well, we're excited to have, like you said, not only to have somebody in studio, because it's very rare, but to actually bring this new information that I just read about the article just a few days ago. So this is brand new off the
Isn't that funny? And I had also read it, and you had mentioned it to me, and then you said you got it, because I just read it, not even knowing that you were coming in or anything. I said, oh, yeah, I read that. It's amazing, isn't it? He's like, yeah, well, I got him. I'm like, oh, that's great.
Well, I know Ron wants to take the first question. Go
first question. The first thing that came to mind, I watched some of your stuff, which is all fascinating. We're talking about dinosaurs, pterosaurs specifically. And nowadays, we always hear that what we think are dinosaurs are actually, in fact, birds. That's what they always say now. They were birds or in the lineage of birds. And then I thought to myself, well, there is one bird of dinosaurs I remember. It's a pterosaur. That's what
Wrong.
Right? And then I heard you say a pterosaur is not a dinosaur.
That is true.
So now I've got this quandary. My mind's all locked up. Can you help sort it out for us all, please?
Sure. So there are a lot of really cool fossil reptiles from what we call the Mesozoic, right? So there's three periods: Triassic, Jurassic, Cretaceous. Goes from about 250 million years ago up to about 66 million years ago. And on the land, basically, the world is chock full of dinosaurs. That's why we call it the age of dinosaurs. In the seaways, you've got all kinds of other weird marine reptiles. Again, we're not dinosaurs, not even all that closely related. And in the skies, you've got pterosaurs. And pterosaurs were not dinosaurs, but they were probably fairly closely related to dinosaurs. There's some controversy about that, but we're pretty certain that they're quite close to dinosaurs. And the thing to understand here, and one of the questions I get a lot is, what do you mean it is or is not something? It's all about what the most recent common ancestor is, right? So you are something, in biologist speak, you are something if you're descended from that thing. So if you go
hence
back
the bird thing. Birds are dinosaurs because they're descended from dinosaurs.
Right.
Exactly. Right. So if you go back in the bird lineage, you find the first bird. Who's it with in terms of its family tree? It nests right in with dinosaurs. So that means they're dinosaurs because they're descended from dinosaurs. If you go back to find the first pterosaur, the ancestor it shares with dinosaurs. It's further back. It is that animal is actually not a dinosaur.
Well, that's actually, I'm so sorry to just jump into this, but that is one of I had a few questions. That's one of my questions. What did this descend from? Can you, since you're right there, why don't you tell us? Because what did this originate from? I want to know, were there little pterosaurs and then they ended up growing to some huge size? Or did they just appear at this enormous size?
Because they're huge.
Crazy.
Some of them are absolutely huge. Well, for our cool critter, our new animal, Cryodracon, we can say that particular animal was descended from a much smaller pterosaurs. Now, we don't really know exactly what the first pterosaurs or the sort of immediate ancestors of pterosaurs looked like because we don't have a good fossil record of that yet. So the answer to your broader question is actually I don't know, neither does anyone else. And if someone figures it out, that will be...
Let you know.
Yeah, that will be like the PhD
Tony,
of the century.
Give me a minute.
Okay.
Yeah, there you go. Figure it out. And that has to do with sort of basically just luck of the draw. So we know more about the origins of groups that happen to originate in time periods where we have a good fossil record, and that's just kind of a matter of happenstance. So we know a lot about the origin of birds now, and the reason is because the first birds show up in the mid to late Jurassic, and we have a ton of late Jurassic sites. That's why late Jurassic dinosaurs are so famous. I'll give you some examples of late Jurassic dinosaurs. I guarantee you've heard of them all: Stegosaurus, Brontosaurus, Apatosaurus. Okay,
right.
Brachiosaurus. all late Jurassic stuff. Amusingly enough, despite the name, Jurassic Park doesn't have a lot of Jurassic dinosaurs in it. It has a handful.
Right, isn't that funny? I always thought that was so funny.
Most of them are Cretaceous, but they didn't think Cretaceous Park sounded as cool.
Right.
Right.
But in any case, the first pterosaurs we're fairly certain are showing up somewhere in the middle Triassic, because in the kind of late Triassic is when we're getting the first pterosaurs. So presumably just before that is when the very, very first ones would be around, and we just don't have a lot of places in the world where you can.
And the
fit
first ones
fossils
were
in that.
tiny, smaller.
Or at least smaller.
Smaller.
The earliest pterosaurs we have are and they're smaller. They're like blue jay size. They're smaller in the crown.
That's tiny.
They're pretty small. Yeah, tiny by comparison to what we're used to.
Totally.
And in the Cretaceous, the average pterosaur in the Cretaceous, so tens and tens of millions of years later, so in the later part of the age of dinosaurs, those things, the average one is like a 5 meter, so 15-foot wingspan. That's like a typical 12 to 15-foot wingspan would be like your typical pterosaur. That would be like as common as like a seagull is now. Right, you just you look out, if you
15
look
foot
at the window
bird.
of your time machine, you take a time machine, you look at, oh yeah, this is a flock of 15-foot wingspan
couldn't you
animals just
imagine?
flying around. And the main specimen of Cryodracon, our new creature, new awesome pterosaur that we've just described this week. That animal, the main specimen that we've attached the name to, had about a 15-foot wingspan. But there's a single bone from a much larger pterosaur, also from the same area in Alberta, that may also be Cryodracon. So it may be just a much larger individual. We're not sure. Yeah, it could be slightly different species, or because Cryodracon is what we call a genus name, or it could be another individual that just lived longer and got bigger. That animal, though, would have been more like a 30-foot wingspan.
Oh my God!
See, this is getting crazy. I looked up that the heaviest bird that we know today. You'll probably correct me, but that I could find is this Cory bustard or something like that.
That holds the record.
It's a 40-pound bird, and this is the biggest thing, the heaviest thing that we can get in here. Why don't you tell us how the biggest one of these pterosaurs gets to be? You can hang on to your seat over there.
Yeah, Ken. So the largest pterosaurs that we know of, it's kind of a dead heat between three of them that all seem to have been around 600 pounds or so.
How in the hell you get 600 pounds up and
Exactly, Tony. Exactly. How do you get that in the air?
Well, you get a very large slingshot and a couple of friends.
right?
Drunk
one
I don't mean how you personally. How did
I'm
they?
sorry. Okay.
Yeah.
80 million years ago, how did they get up in the air?
I thought you were asking about a college story.
Right.
It's, we'll come back to that.
Right.
Anyway, it starts with, "Hey, watch this, hold my beer." But yeah. Well, the first thing to note, before we get into kind of the mechanics of it, is to realize that part of why this seems so crazy and amazing is kind of a trick of luck, if you will. Right. So we happen to live in a time period that just doesn't have any big flying animals. 40 pounds is not the biggest a bird can get and fly. It's just the largest flying bird that is alive now. If you took our hypothetical time machine back just a couple million years, you could actually find birds with wingspans of over 20 feet.
Right, and they looked like eagles, like basically your standard regular bird, not a pterosaur-looking animal.
Still
Right.
bird,
They look like
still
a bird
feathered
bird.
bird. Yeah,
Right,
yeah.
feathered bird.
But yeah, still true bird with feathers and everything.
Yeah.
And they're still nowhere near pterosaur weight, which I'll get to in a sec. But nonetheless, a bird can get a lot heavier than 40 pounds and still fly. So that's just kind of a happenstance of the fact of the time period we're living in. We're living in a post-extinction
A lot
world.
heavier,
A lot
though.
of big things are missing.
You're talking between 40 pounds and 600.
Yeah.
Right.
A lot heavier to me is like 70 pounds.
Yeah.
600. And what kind of wingspan are you talking about there? 60?
No, the largest would be about 30 feet. So
30 feet and 600
30
pounds.
to 35 feet, about 600 pounds. Standing on the ground, they would look at a modern giraffe in the eye.
Holy crap! I bet you that the wind just off of those wings would about knock you over.
Just about, or it could just swallow your dog
Right,
whole.
right.
And maybe a small adult. So there's obviously something going on here. So I'll lead this off by saying that the estimates of the largest a bird can be and fly are about 100 to 150 pounds. So you can actually have a true bird, just straight up bird. The way they take off, it looks like it should work up into about 100 to 150
So they had
pounds.
to fly differently then. I mean,
Well, they have to take off differently.
Differently, okay.
That's the key.
So it's the launch.
It's
That's
the
the big
launch.
key of this whole thing that I never heard in my life. It's the launching.
Yeah, if once you get going,
Right.
you could stay up at even bigger sizes.
Boeing 747 weighs right.
Yeah,
right.
but the problem is you need enough launch speed.
Do they have to be like maybe on
go.
top of a mountain, or I mean, what is it to?
Well, that actually doesn't help that much. That was very popular for a number of years. And,
Or they just
and
go
I
Like,
was-
that was the going theory. That
Yeah.
They thought that these things would just went off the wind.
And yeah, and then I burst everyone's bubbles by showing massive.
I say, yeah, he's the guy that does
This
it,
is
right?
the man.
Yeah. So anyway, the trick comes down to how hard can you jump? Because that's how animals initiate flight. Basically, is jumping. Some of them will run over the water and initiate flight that way. They kind of run into a jump. That's kind of a different ballgame, though. We're not talking about water launch. That's a whole different
Right.
ballgame. We have no evidence this thing lived in water. So we're just looking at land takeoff. And there, your best bet is to jump as hard as you can. Now, a bird.
I never knew that.
A bird has 2 legs to jump with, right? Its legs. It's 2 limbs to jump with. Its wings don't help much. About 90% of the launch power comes from the legs, not from the wings. The wings start to come down as the toes come off. They get a little bit from that, but basically they're taking off with the legs. Now, the problem a bird has is that means it is now separated into 2 motors. Okay? It's
Right.
got a takeoff motor, which is the legs, and it has a flight motor, which of course is the flight muscles, chest muscles that run the wings. And if it makes the wing muscles bigger, it has to push harder to take off because it's got more weight to take off with. That has to push into the air. If it makes the leg muscles bigger, those are now payload when it's in the air, so now it has to yank them around. So at some point, you get a catch-22 where you either can't take off or you can't sustain flight. And that seems like for birds, it probably would happen around 100, 150 pounds-ish. We're not sure.
Right.
But that's the best estimate that we've got. Well, I think it's the best estimate we got because it's my estimate. But go figure. But I'm the one who did the math on it. I put in the
Right.
hard work on
The
it. So I get to
royal
do that.
we.
The royal we.
I don't
exactly.
think we're going to
Yeah.
challenge you at all.
Yeah, fair
so-
enough. Well, and to be fair, other people have also run the math subsequently to kind of validate it, and they got the same result I did. So
All right, so give or take, though, I
Give or
mean,
take.
we're in that ballpark.
yeah, in that ballpark.
And
So
now
then-
you're still talking.
Then it's 600 pounds.
Right.
So how do you
see?
get another 400 pounds?
Right.
on it?
Right.
Okay. So
Right.
the way you get the other 400 pounds is you break the bird catch 22. Pterosaurs, as best we can tell, and actually we can tell very well because we have trackways from them, were what we call quadrupedal. So quad for 4, pedal for foot. They walked on all 4 limbs. So the wings fold into walking limbs. They're walking on their feet and their hands. Now that changes everything because now when you jump, you're not jumping just off your feet. You're jumping off your feet and your hands. And your hands are connected to your flight muscles, which are the biggest muscles you've got. So pterosaurs get launch duty out of their legs, and they get double duty out of their flight muscles, both flight and takeoff. And that means that if you make your chest supersized on a pterosaur, you don't have the problem that a bird has if it does that, because you can use that muscle to take off and for flight, so you get double use out of it. You don't get stuck between a rock and a hard place, mechanically speaking, the way that birds do, and you can just blow the ceiling off the weight limit. You still eventually hit a limit, but it's hundreds and hundreds of pounds more.
It's at least 600.
Yeah.
Yeah.
600.
Yeah.
Right.
Don't bats do that same sort of thing? Do bats have some?
There are some bats that do that. So bats are weird. Some of them can't take off the ground worth a damn, and some of them are really good at it. And the ones that are really good at it, like vampire bats, for example, they can gallop around on all fours and stuff. And they also take off the same way. So these their feet and their hands take off. And just like pterosaurs, because of that, they're really supersized up front. So bats have relatively, even the ones that take off powerfully from the ground, like vampires, they have kind of average hind limbs, or even maybe a little bit on the weekend, and they have supersized chests. I mean, it's like they're skipping legs day all the time, and they're just doing
Which is
nothing.
different than how they many times depict pterosaurs, right? They don't
That's right.
have this. Like Rodin does, but typically you don't see that.
Right, but if you actually look at the skeletons on pterosaurs, the front end of them is totally supersized. They're, in fact, the big Cretaceous pterosaurs, these things like Cryotricon that I work on a lot of the time, they look like, I've actually had, so I freelance in the entertainment industry doing creature design stuff, and I work with some top creature designers doing film and TV creature design stuff. And I've also done a lot of documentary things, and I'll give them sketches or measurements of pterosaurs. Like,
Did you do Rodin?
no, I did not do Rodin. But
I mean, that would have been your right up his alley.
that'd be right up my alley. Yep. I wasn't the one on that one. I can't. They may have used some of my data. I don't know, but I wasn't a consultant on that one. But they I've had people not believe me. Because these late Cretaceous pterosaurs look like you've taken an average sized reptile and a giant reptile and like the back end of one and the front end of the other
Right.
and bolted them together. It's stupid. to give you an idea how stupid it is, because it's not just the chest and arms that are supersized. The head and neck get supersized on them too, because it seems like it kind of just becomes a developmental trend.
Oh, and in Tony's photo here, it looks like a depiction here. It looks like the head's half the body.
It does look
Yeah,
like.
actually, in fact, it's probably a bit more than that.
The head?
The head.
Really?
If you do it by length, on like Quetzalcoatlus, for example, or on Cryodracon, on what they call them Ashdarkid pterosaurs. It comes from an Uzbek word. It means dragon, so the dragon pterosaurs. So on the dragon pterosaurs, the head length is regularly 3 to 4 times the length of the body. The length of the body being taken is the shoulder to the hip distance.
So the body's going to be 25% of the whole body? That's all head.
Oh yeah, it's even less than that, because the neck on them is long or longer than the head.
This is an incredible creature. It's
ridiculous.
It's like an alligator, like a super croc on.
Right.
It's amazing.
Now,
it's nuts. Well, it's kind of like you took your average sized reptile body and put a super croc head and neck on the front of it,
God.
and then made it fly. That's essentially what you've got.
because I mean, it resembles, I mean, several birds now. I mean, like a pelican-ish from. So that it.
Yeah,
There
but
are
still
some
the
big-headed birds.
But
yeah.
the percentage of the beak to the body on that does not seem like this.
Well, here's another one that
Yeah, it's not this
compares to a
extreme.
human,
Yeah.
a human and the bird. That's huge.
That's a diaper filler right there, Tony. Look at that.
Yeah,
thing.
that'll mess you up.
right.
God.
It's about my best estimates, and I got some colleagues who've done similar estimates of the sort of the chest and flight related muscle mass of all the forelimb kind of muscle mass on these things. It's about 30% of the total animal's
Holy
weight.
crap.
So it doesn't just manage to take off at 600 pounds. It takes off like a rocket at 600 pounds.
How does because of the balance of the weight, if the head is majority a big portion of the body, how they must have really, because nowadays the birds, mostly the body is the weight.
Right.
So that is another flight risk there.
So it's a little weird. It's a little weird. And this is one of the things I've been working on most recently. And I've got a couple things coming out actually that address this very issue. Article in Scientific American coming out just next month, and my book also looks at it in detail. That's coming out in early 2020. But it turns out having a giant head and neck as a flying animal is not as much of a problem as you might think.
Really?
Yeah, and they're cheating two ways. So first of all, they're just kind of outright cheating in the sense that the head and neck are big in volume, but not necessarily as large in weight as they look, because they've got a lot of airspace in there. The neck bones on these animals, the neck vertebrae are like hollow tubes, and there's all these huge air spaces in the skull. It's not like it's not as if they've taken the whole head and made it big. It's just the front of the face. It's just the jaws. They've got an average size brain case on there with a fairly average sized brain, which is the heavy bit, right? And then they have this big vaulted skull with this huge opening in it that's filled with air. So it's kind of like you have a styrofoam skull on the front, so it's not as heavy as you might think.
Okay.
So that's one trick to doing. So they're just kind of cheating a little bit until you look at it like, oh, must be so heavy. Well, it's not as heavy as it looks. And of course, the muscle, which is dense and heavy, is mostly in the chest, right? So that brings the center of mass back a little bit. But it's still big old head and a big old neck, and there's still some muscle and stuff in there and other tissues, and it's still way the heck out in front of this animal. It's ridiculous. But we're thinking about it as walking animals. If we have a center of mass way out in front, we have a hard time walking. We just pitch over because we have to keep our feet under it.
Right.
But for a flying animal, that's no big deal. The trick is you just have to have the center of lift lined up with the center of mass, and they don't have fixed wings like a 747. They've got joints. They can just move the wings, and the center of lift on a wing is closer to the front of the wing than it is to the back of the wing. When we look at a wing visually, what our brain wants to do is assume that the center of lift is at the center of area, right? What we can see, our eyes are very good at finding what we call the centroid of shape, right? Where we're the center, basically we're good at finding the center of area or center of mass of something, but that's not where the center of lift is. The center of lift is much closer to the front end of the wing. It's at about a quarter distance back from the front of the wing. Quarter of the total, what we call quarter, the whole front to back distance of the wing. So it only has to get the front of the wing lined up with the center of gravity. And in order to do that, all it has to do is bend the elbow and sweep the shoulder a little bit and bring the wings up. So it just puts a little forward sweep on it.
That's it's fascinating how they master it. I mean, it really is. It's so fascinating.
It's amazing what you can do when you're flying by thought.
Right. That's
right.
what I'm
I mean,
saying.
there's nerves and everything, muscles running through all this wing. We know it's really muscular because we have wings preserved, with some of the soft tissue preserved in some of the fossils of some of these pterosaurs. I mean, not the original tissues necessarily, but we have fossilized soft tissue, so we can tell based on like the original fiber direction, what that was, and the fiber size, and that tells us what kind of tissue it was, and a lot of it was muscle. So they have this muscular wing, which means it's really responsive. So you get a little gust of wind at one point, the wing can just change its shape a little bit and adjust.
That's just fascinating.
And all this could just happen reflexively. Like just all the little adjustments you make with the bottom of your foot every time you walk on an uneven surface.
Because we don't even
just doing
think
that with
about
its
it,
wing.
but,
Yeah, we don't think about it. Yeah, we walk by thought. Well, they're just flying by thought.
But it's
Right,
almost
we're
like
keeping
when
our balance.
Yeah. But, you know, it's like my mother when she actually had diabetes and she lost a toe. She had to learn a little bit figuring out how to walk again correctly.
Yeah, but I'm sure she did.
Oh, she did.
And
you don't
for long, you couldn't tell the difference. Yeah,
I want to talk about this. Was found in Alberta, Canada.
that's right.
And you said that originally they found it in the 60s. They just didn't. They found pieces of.
Sure.
Correct. Could you talk about how it was discovered?
Yeah, absolutely. So a little bit on the history of this critter, because it's sort of interesting. Actually, quite interesting, I think. So there were pterosaur finds in Dinosaur Provincial Park, some of which is probably referable to our new animal, as far back as the 60s. It was really looked at for the first time seriously in the 80s, and there's some references to the material in the 80s and particularly in the early 90s, where the material was actually published, and they identified that it was pterosaur material, and it was from a large pterosaur, and they could tell what kind of pterosaur it was. But there was a problem with identifying it as a new species. So it's not like we noticed some fundamental thing that other people had looked at and just didn't know, didn't think about or made some terrible mistake or something. It was actually an information problem. So in order to determine that something's a new species, you have to go and look at all the other things it could be. Things that you narrow it down, the kind of the group to a particular group of organisms. Okay, well, I can tell at least at a quick glance that it's something like this. And then you go in and you look at all of the this and see whether it matches. And if it doesn't, then you've got something new, right? And that's how you do living species too, right? If I go out there and I find a new little songbird in the rainforest, I have to compare my new little songbird to other songbirds that are generally similar, right? To all the things that it could reasonably be. I don't have to compare it to eagles because we know immediately it's not an eagle. But if I could tell it's a finch, I need to compare it to basically all the other finches that are similar, right? And if it doesn't match any of them, then it's a new finch. Well, same thing here. The problem is the obvious comparison. There are a few you could get to. There's some stuff that these pterosaurs are known, or these kinds of pterosaurs are known from Asia. They're known from Europe. They're known from the Middle East. So they're known from a number of different places. But the obvious one to compare it to would be the North American one.
Are there a lot of these?
There's not a lot of specimens. They're fairly rare, but they're.
No, I guess I meant, are there a lot of species of pterosaur?
Oh yes. Well, fair number. There were probably many, many more that we haven't found as fossils, and we may never find a lot of them because they're just rarely preserved. I think at last count there's like 170 species, something like that.
So you're trying to compare among those 170 which one this might be.
But that's what I'm saying. When you said you find a finch, well, you physically have a full bird in your hand,
right?
And you said, okay, comparison, but with a partial bone or just a few bones, how do you even come close to determining?
Well, if you only have a few
what
bones,
is what and what's a new species,
right? Well, sometimes you can't. Sometimes if you just have one partial bone or a few bones,
right?
Sometimes people will try to put a new name on that, and it doesn't always stick because it turns out that there really wasn't enough to go on. We call it a nomen dubium, dubious name. Right. And you're not really supposed to do that. Now, for Cryodracon, we have actually a partial skeleton. We've got a lot of bones. They're not crushed. They're three-dimensionally preserved. We've got a bunch of it. And then we have individual bones from a bunch of other individuals where on their own they wouldn't tell that much, but because we can match it with the partial skeleton, we can go with that. So we've got plenty to go on. And we don't have to compare it to all 170 or some species of pterosaur. We just have to compare it to the other ones that it could reasonably be, right? Which would be these other dragon pterosaurs, these Ashtarka pterosaurs. And the one that we really needed to compare it to, because it's the one that had been tentatively assigned to it previously. They thought, oh, well, maybe it's this thing, was this animal from Texas called Quetzalcoatlus. Which is named for the Aztec god Quetzalcoatl.
Oh, okay.
And very, very cool animal. The problem is Quetzalcoatlus was originally discovered in the 1970s. It was the original giant pterosaur. It is still tied for the record of largest flying animal of all time, although it's now tied with Cryodracon, our new critter, as well as an animal called Hatzegopteryx from Romania. And Yeah, they found a giant flying animal from Romania, and the best they could do was a name that means winged animal from the Haytig Basin.
All right.
Yeah, okay. As a Dracula fan, I was grossly disappointed. But anyway, but regardless, the thing we really would want to compare to is Quetzalcoatlus. Quetzalcoatlus was found in the early 70s, written up in basically the mid 70s. But when I say written up, what they found was a mostly complete gigantic left wing, and then a number of partial, in some cases, fairly complete skeletons of things in about that 15-foot wingspan range. Well, they were so excited by this giant wing that it implied a 30-foot wingspan animal or so. And at the time, that was the first time that had happened. Now we know there's actually quite a few of them flying around the late Cretaceous at that size. What happened was the discoverers published that part, named it Quetzalcoatlus northropi, like Northrop is in Northrop Grumman, and then didn't do anything else with the rest of the material for years. And then in the 90s, they published a few of the skulls, and that was it. And so we had this problem that most of the Quetzalcoatlus material, what you need to compare Cryodracon to, was not published. And it was being worked on for years and years and years by a fantastic paleontologist by the name of Juan Langston Jr. But unfortunately, he taken ill and he died in 2013, and he never got to finish that work. And while he had been working on it for all those years, it was basically under embargo because he essentially had the kind of dibs, essentially. Right. And he was one of my mentors. I think the world of him. I do feel like he probably should have handed it off sooner, because over 30 years worth of embargo is rough. But regardless of how one feels about it, he was working away on this, and it wasn't available for most people to look at. And that meant that when other researchers had looked at Cryodracon material in the 80s and 90s, they couldn't tell it wasn't Quetzalcoatlus. Not because they compared it and they didn't see the differences we saw, because they couldn't compare it.
Right.
But I was one of a handful of individuals, I think maybe one of 3 people, who was allowed access to Quetzalcoatlus in the early 2000s in my particular case. So Juan Langston Jr. Let me work on it. So I actually had the measurements and the notes. So when I was working the Royal Tyrrell collections in Alberta, Canada, and Drumheller specifically, and I saw this pterosaur material, I sort of immediately recognized it didn't match because I had seen the other stuff.
That had to be really exciting at that point, right?
Which was super exciting. Yeah. It was super exciting. Now, that said, what we call systematics or taxonomy, so that these kind of telling what a new species is and describing that new species, is not actually my focus area. I'm decent at it, but it's not my specialty. My specialty is the mechanics, like the takeoff and the launch and the flight speeds, all that stuff we're talking about. You could probably tell from the way I talk about it. That's my thing. So what I ended up doing was calling up my friend David Hone, who's a collaborator and friend of many years, who does do that as a specialty, and said, "Hey, Dave, I'm looking at the pterosaur material up here in Drumheller, and it's not Quetzalcoatlus, but I need some help to work on it." And so it ended up being a team effort between Dave, who flew in from England. He works in London. He's a professor at Queen Mary University. And Francis Walterian, who's a curator there at the Royal Tyrrell Museum, who's the one who originally gave me access to the material and said, "Hey, Mike, you should take a look." And myself. So the 3 of us wrote up our new critter, and it is now, we've been able to demonstrate it is new. It's in the Journal of Vertebrate Paleontology. It's called Cryodracon boreas, which means frozen dragon of the north winds. And
that's better than that Romanian thing, huh?
Right. Yeah, much better than the Romanian thing. And for those who are wondering, for those who ask, I get asked this a lot, is it named for Game of Thrones? Officially, no.
You wanted to?
But unofficially, it was an inspiration for using the Frozen Dragon reference. And actually, I wanted to go whole hog on it. And I wanted to call it Cryodracon Viserion, named after the dragon Viserion for Game of Thrones, who is the dragon who who's killed and resurrected from a frozen lake. But they wouldn't go for it. They said that was a little too much showboating. And I understand that.
I'm sure people would appreciate it.
Yeah, I'm sure they would appreciate it. So officially, it's because it's from relatively far north. It's one of the furthest northern occurrences of a of a pterosaur that we have, and that area, of course, is frozen much of the year now. That was not frozen at the time this animal lived there. So one thing to note is it was not living in a frozen world. It was living at fairly far northern latitude, but overall global temperatures were much higher at the time. And in fact, there was an inland seaway that was splitting North America apart at the time. So it was living near a coastline in conditions kind of like modern day Louisiana. So it was very warm, temperate to near tropical. And pretty humid and all that kind of good stuff. So that's the world it was living in when it was living and breathing and eating and flying. We are referencing what that world part of the world is like now from where we found the fossils.
Right.
So,
I have a couple of questions. First of all, some people in the chat room wanted to know about, do you have slides? I don't want to pull the wrong information up. So, are any of these? Do you have? Is there actual bones or any that people can pull?
So I think the top two. Yep, where you just moused over. Yeah, that looks like
so. There's
critter. Yep, and that's at the bone of the neck, and then the other one is actually the with the weird. It looks kind of like a hatchet. Yeah. So that thing is in fact the humerus. That is the bone of the upper arm. Okay, so you'll pull up there in a second. And the reason it looks like a hatchet, whereas ours just looks like a long tube, is that big blade on it is where the flight muscles attach.
Oh, okay.
So we have the same ridge, but for us it's just a tiny little bump. It's where like our deltoids and pecs attach.
Right.
And we may be very proud of our deltoids and pecs, or if you're like me, it's nothing to write home about. But
Why are you looking at Ron?
working on that. But I mean, no matter how impressive you think yours are, it's nothing compared to a flying animal. Cryodracon's got you beat on pecs any day of the week.
How do these bones survive? I mean, is it just fossilized, or how do they get fossilized? So, where majority of the bones maybe deteriorate?
So this is fairly typical fossilization. You can get some weird kinds of fossil processes. In fact, one of the most famous, if not the most famous, alternative kind of odd, rapid fossilization is on display in a big way here in Los Angeles. It's the tar pits.
Oh, yeah.
Okay.
Yeah.
So there you've got asphalt that basically invests these bones and essentially fossilizes them very quick, semi-instantly. But what normally happens is they're fossilized by mineral replacement and investment from the surrounding sediment, basically. And what that requires is that the thing not get super degraded before it gets buried, which is what happens to most of the skeletons. Most of the time something eats it, chews on it, or it's just blown apart by wind and rain and whatever. So it has to survive all that. If it survives all that and it gets buried, especially if it gets buried fairly quickly in fine sediment, then over time, minerals from that sediment will invest in the bone. Those minerals make it essentially permanent. Most of the original organic material will be lost. Sometimes a little bit of it can remain, we're finding, especially in the deep interior of big bones. In bone the size, probably wouldn't be any left, but it'll replace most of it. Some of the original minerals, some of the original calcium, phosphate can still be there, but mostly it becomes inorganic minerals, inorganic source minerals. And those, or I should say non-biological, the minerals are technically non-organic, but you know what I mean. Anyway, and it gets replaces the original tissues of the bone, and that will essentially preserve it indefinitely. Of course, then what you've got is the sediment around is compacted and turned to rock, so now you've got something that's rock-like embedded in rock, and it'll sit there for tens of millions of years, and if it never gets brought to the surface, it could basically just be there forever. But we'll also never find it. So, in terms of finding these things, it's like threading the needle, because it has to get uplifted at some point by some kind of geologic forces, of which there's many that can do it, and then the sediment has to get eroded away. The rock has to get eroded away until some of the fossil is exposed, so that we can see it, so we know it's there, so we can excavate it. But if we don't happen to come across it during the time it starts to get exposed, it'll get more and more exposed, and it'll just get eroded away. And it can go go from beautiful and complete, like you're seeing there, to basically pulverized in a couple of seasons in some parts of the world. Depends on where you're at. Alberta wouldn't be one of those places where it pulverizes very quickly because you get ice for part of the year, right? And the ice will just break things up. So you get water in there, it freezes, ice breaks it up, and then you get a thaw, and you get a refreeze and a thaw, and a couple of those, and it's just pulverized the rock. Ice just takes takes rock apart, and it takes fossils apart too. So those areas,
look at glaciers,
as soon-
I mean,
yeah, exactly. Look at glaciers. I mean, they just take boulders, just rip them off, and just drop them wherever they want.
Right,
yeah.
right.
Yeah, I often joke that the two things to really fear are water and fire. Those are the two things that win basically all the time. The water will eventually win. That's why I don't mess around and try to do plumbing myself. I'm like,
Right.
yeah, no, I basically understand the mechanics of what's going on here, but I'm not going to mess around with this myself, because if I get it wrong even by a little bit,
Yeah.
I will destroy the entire kitchen.
And quadruple the price.
And quadruple the price. Yeah, exactly. Yeah, yeah. Water. Don't mess with water. In its frozen or liquid forms.
Right.
So, in any case, yeah. So it's kind of this funny thing where a number of different special things have to happen. Has to get buried rapidly in the right kind of sediment without being degraded first, without breaking down first, and then it has to undergo the right process to turn it into a fossil, have the right minerals that turn it into a fossil, and then it has to get re-exposed.
So
And the
it's a long
re-exposure
process.
has to be relatively brief before we get there, or else it's gone again. Forever.
So this is one of those, again, it's one of those things where it has to be perfect. It's like a
Right. 1 in a million shot, Doc. Yep.
Yep,
So
yep.
think about all the stuff we never knew.
Right.
Yeah.
Because now, I mean, this is way before, but we never did say the exact, how many millions of years ago do you believe that they existed?
So our particular animal, so Cryodracon, is from rocks that are dated fairly confidently to, I think it's about 73.5 million years. I think it's the last
Wow.
dating on it. Yeah. So which is a good bit earlier actually than say Quetzalcoatlus, which is from more like 66, 67. Which is one of the reasons why prior researchers who looked at it prior to our looking at it, and to my kind of eureka moment there in the museum, already thought maybe it wasn't Quetzalcoatlus. They just couldn't prove it because it didn't have any data, didn't have any evidence.
Right.
But the one bit of evidence they did have was, that would be a
million years.
long time. 8 million years of time would be a long time for one species to last.
Right.
At least for this kind of animal. Different kinds of animals and plants have different sorts of clocks in a way in terms of like not only the individual's lifespan but sort of species lifespans. So like 8 million years is not a big deal for say a mollusk species to survive. We have snail fossils from 6, 8, 10 million years ago that are basically
same.
identical to modern
Right.
ones. But from what we can tell for most terrestrial vertebrates, big vertebrate animals, big backbone animals, things like dinosaurs and mammals and such, most of them kind of live more in the fast lane. So from a species standpoint, it's kind of live fast, die young. And 8 million years would be a long time. 1 would be more of what we'd expect.
Wow.
I have something to ask you here. Okay, so exactly what you're talking about now. So we've had sharks supposedly have remained the same for 60 million years or whatever, a long time, right?
Well,
Alligators
not quite so much actually. Yeah.
Oh, well, they say that alligators and sharks, I always hear that they go back.
Those are classic examples, and it's partly true and partly a myth.
Okay.
So those lineages go
Get him,
back
Doc.
a long way, but they aren't that modern looking if you go back far enough. So it's a question of whether you're talking about modern looking sharks or just sharks. If you mean just sharks, something that's identifiable as a shark, they go back hundreds of millions of years. If you mean the modern groups of sharks, goes back into the age of dinosaurs for some of them. Some of the others are not.
Well, that's an
much
incredibly long time.
That's still a long time.
You said 8 million is a big change. This is more
for a
than
single
that.
species, but we're still talking about a group. So like the great white shark, like the living great white shark, doesn't go back 8, 10, 20 million years. Great white shark like sharks go back tens of millions of years.
Gotcha. Yeah. So, okay. So, but because they say what the little tiny, layman's knowledge I know about this is that these two animals, shark and alligator, have survived all these millions of years because they're just perfectly made killing machines. And like they're the top apex predator in their domain. Alligators, sharks, whatever. This beast can fly, apparently has some aquatic abilities, can be on land. Its head's that big. It's an eating machine. I'm shocked that nothing like it has survived at all.
Well, almost nothing with an adult body size more than about 40, 50 pounds survived the Cretaceous extinction.
Well, what about alligators?
Small ones made it through. The big ones, the crocodilians and alligator relatives, they also suffered major extinctions at the end of the Cretaceous. It just didn't kill them to zero. That's the key thing in biology. There's a world of difference between 2 and 0, right? Yeah,
right.
yeah. So if there are none left, you're done. If there's a few left, you come back. And I mean, birds got hammered in the Cretaceous extinction, but some of them made it through. Alligatoroids got hammered at the Cretaceous extinction, but some of them made it through. They didn't get hammered actually as bad as others. They did survive better than a lot of things. So alligators are a pretty good example of something that was able to deal with it to some extent. But they still, a lot of them died. Sharks, a lot of sharks got hammered. The big top kind of, top predator sharks, most of them didn't make it through either. We ended up with new ones from related, slightly smaller, less badass species. Wow. They got badass again. So basically, when a giant rock falls out of the sky and melts part of the crust and actually vaporizes it and sets much of the world on fire, you kill the badass stuff, and then other things evolve to be badass later. And the reason is because the things that we tend to be really focused on as charismatic, big, badass things need a lot of resources, right? They need a lot of space, they need a lot of food, whatever. They just don't take these hits very well. And there can be other more specific things. Being able to fly might not have been such a good thing for these critters at that particular time. It would have been great for 160 million years. Being a big flyer was awesome. It made them, nearly indestructible, probably on an individual level, on a daily basis. I mean, the only thing you could take down Cryodracon would be like a big predatory dinosaur.
If he got him in time.
If he had to get him in time.
Like a rocket.
Yeah.
To me, this thing should be living now. I don't know who would stop this.
Yeah, right. I mean, if it was alive now, it would be pretty much unstoppable. By the way, the launch time on that, the estimated launch time on that thing is about half a second. At the end of which,
600-pound beast.
600-pound beast launching in half a second. By the end of the launch sequence, it's going faster than anything at the time could run. So you have to catch it by surprise and have to also hope that it doesn't turn around with its 9 to 10 foot long sword of a face and just skewer you. So so how do you kill this?
How would it ever die?
It has an Achilles heel. It is a big enough flyer that there's no way that it was able to flap continuously. It was a powered flyer. It's not the passive gliding thing.
It's like me running 50 yards. After 50 yards, I'm pretty exhausted.
They're pretty exhausted, right? So,
but he doesn't need to, because once he gets up,
right.
Once he gets up, so here's the trick. If you're a big flying animal, you have anatomy and muscle physiology. We can estimate the muscle physiology knowing from what we know of living animals. That's very sprinter oriented. You're able to flap very powerfully for maybe a minute or two, right? And then you tire out. So then you have to find other ways of staying up. Things like thermals, like warm air rising from surfaces and things like that. Now you can go so fast and so high at that size that even for those bursts, you'll cover a ton of ground and you'll easily find another thermal. You'll easily find what's called cloud street. You'll easily find ridge lift. You'll find something you can soar on for sure, unless an asteroid has recently plummeted out of the sky, cooked the entire atmosphere, and made soaring conditions completely unsuitable for at least, say, 6 to 12 months, which is enough time to starve to death every big pterosaur on Earth.
Unbelievable.
Now, with the fossils that you find, or any fossils, is it ever possible to get any type of DNA sampling? Or is it because it's fossilized, there's no tissue left, and then you can't pull DNA testing?
So you can potentially get DNA out of fossils, but not of the age that we're working with, and not typically of the type we're working with. So you can get DNA out, a little bit of DNA out of much younger fossils, particularly in amber. And you can get, and even now, if you go back to like Age of Dinosaurs, age stuff, Cretaceous age stuff, you can get some original soft tissue. There's an individual worker named Mary Schweitzer who's been particularly leading this work, and her team has found ways of actually extracting original soft tissue, but it's proteinaceous stuff. It's not DNA. They're getting collagen and things like that. It turns out that under the right conditions, that stuff will last tens of millions of years. If it's entrapped, if it's fossilized, it's not fossilized. If it's trapped in material that fossilized very rapidly and preferably fairly far from the surface of the element, so a big bone, right? So deep in a big bone, they're getting some original soft tissue. They're not getting DNA. Now, unfortunately, even if you're talking younger, even if you do get a little bit of DNA, you still can't really do much with it. So DNA has kind of a weird quirk. It only has a 4-letter alphabet, right? There's 4 base pairs. Now, if you imagine how long your words have to be, if you will, with such a small number of letters, to make any sense of it, they all have to be very long. So the minimum useful sequence from DNA is really long. And its half-life is not that long. So even if you're getting some DNA, it will be broken. Say you get an amber fossil that's 2 million years old. You might get some DNA from that, maybe. But it'll be really chopped up. So all you'll be able to say is it's DNA. Because it can
that's
match any number of things. Like
Right.
it'd just be garbage. It'd be like if I grabbed random letters out of a novel, right?
Right.
And I've got an A before a T here, and I've got a BL something, and I've got something that ends in
it's just
CK.
not enough, yeah.
It's not enough. I can't tell you what novel that is. I can't even tell you what words those are, right? So it's just it tells me nothing. So there's really not much you can do with that. You can't actually Jurassic Park it, unfortunately. But you can do some stuff with that collagen that's in better shape. Not a lot, but you can at least compare
what
it to
could you
modern
do with
collagen.
it?
We compare it to modern collagen, for example, and confirm things like if we're correct about the relationship of birds as such a wacky kind of dinosaur, then the collagen in Tyrannosaurus rex bones, which has been recovered, should look basically just like bird collagen, and it does.
Really?
There you go.
That's pretty
Birds.
awesome.
Which is pretty awesome.
That is pretty awesome.
So you can do that, and that's pretty badass. Like
Right,
that
right.
that's rad. That's
Yeah.
rad. You're not gonna build a Rex from that, but it's still pretty cool. And of course, if you wanted to play around with dinosaur genetics, we have dinosaur genetics. You can play around with bird genetics. They still have the genes to make teeth. You can engineer birds to have teeth. You can put claws back on them.
Why don't you do that?
They can put long tails back on them. Well, there's people who are playing around with this. Actually,
Well, I was just going to say,
Really? Yeah.
somewhere,
Well, after
some lab
Jurassic
buried
Park,
somewhere,
yeah.
someone's doing something.
Jurassic
Yeah.
Park came out.
Well, one of
I'm
my
sure that
one of my collaborators is playing around with a little bit of this. So it's
What
not
do you
that
think
varied.
about that? I mean, do you think that's morally?
I
Should we?
I would have more concerns with it if they brought it to maturity, and then you've now got this thing living in the world that may have all kinds of problems
Right,
that you've
right.
also engineered into it by accident. What they're doing is these labs are tweaking them, getting expression to confirm that the trait does link with the gene like they think it does in the
Right,
embryo, and then in like chicken embryos, and then they're sacrificing those before they ever hatch.
Well,
Yeah.
maybe, I guess.
Yeah, well, yeah, but somewhere.
Don't forget,
someone's-
we
yeah,
talk about
yeah.
wacky stuff on this show, so
Right,
we
right.
got to be open. We
Yeah.
entertain it. We're not.
Yeah.
Sure.
Well, that's what's public so far. Now,
Right,
yeah,
right, that's
Someone
right.
somewhere may take it to
Because
maturity.
like in Korea, they're cloning dogs like crazy. I tell people they can't believe it,
Fifi died. I want another one.
and they do
I
it.
want another one. Yeah, they'll
That's
do it.
really happening.
Yeah.
Well, then, it's because I want to touch on, because we have a paranormal show, I want to touch on this. Do you think that these pterosaurs are the basis for all the dragon folklore around the world? Because it seems like they seem very similar to dragons.
It's an interesting idea. There is no evidence that humans and pterosaurs ever overlapped in time. In fact, we're quite confident they didn't. Nonetheless, if you found the skeleton of one of things,
That's what I mean, right.
and you don't have a model of deep time and extinction, and you assume every skeleton you find is from something that lived recently, yeah, it could be. It could absolutely be an inspiration for a dragon legend. In fact, I can see. A lot of the dragon stories independently have similar kinds of traits. One of them is often that they're supernaturally tough, right? They've got bones made of something stronger than bone. Well, these fossilized bones are basically rock. So if you find these things and you don't understand how fossilization works, and you don't realize that there's a deep timeline at all to begin with, you don't go, oh, well, they're fossilized because they're tens of millions of years old. You go, holy crap, this is a
strong
giant
that is.
flying reptile that has bones made of rock. We better run away
Right.
because if there's a living one around here somewhere still, it's gonna kick our butt.
35-foot wingspan. If they stumbled across this, you'd see that. You'd see the head on this thing that's 12 feet long, teeth. I'd be like, well, this must be a dragon that died a month ago.
Yeah, I mean,
you wouldn't know.
Yeah, you wouldn't know. It absolutely could be.
And they're worldwide, like dragons.
And worldwide, yep. And one thing I will tell you is, regardless of whether or not they've ever been inspiration for dragons or anything like that in the past, they certainly make great inspiration for them now. And that's why I do so much creature design stuff. Basically, that's what my whole the book I've got coming up is all about. So I've teamed up with a legendary creature artist, and is Tara Whitlatch. A lot of your listeners will probably be familiar with her name. She's most well known for being one of the primary creature designers for Star Wars.
Cool.
and she's done a lot of projects. That's her most famous one. And
Now, what's this film again? I haven't heard of this one. What's it called?
what's it called? Star Wars. I know.
Tony, you want to look that up? We'll see if we got something on that.
I think it did pretty
I think
well.
it's newer.
I think it's done pretty well at the box office. Yeah. It's both newer and older simultaneously. Amazing how that works. But in any case, one of the things we're doing with the book is essentially pitching the idea or really demonstrating the idea that you can build more compelling, more believable fantasy creatures for your story, whatever it happens to be, print, film, whatever your media is, by incorporating some of these fossil animals in there, particularly when it comes to making realistic giant flyers. You want to make a horse-sized animal that's winged, that flies around. Don't blend it with a bird. Bird can't fly at 600 pounds. Blend it with a pterosaur. Pterosaur can fly at 600 pounds.
Right. It's just like the UFO stuff. When these guys tell the alien stories and then they make the movie and the guy's pissed because the movie's nothing like the original story.
Right.
You don't have to embellish the story. Same thing here. A pterosaur, make it as realistic as you think. That's as terrifying as I can imagine. You're not going to outdo that anyway, right?
Yeah, pretty much. Yeah, what really blows my mind is that they didn't go for the largest, scariest pterosaurs for Jurassic World.
Right, they went for the standard.
These literally they got like mid-sized pteranodon, these little dimorphodon and stuff, and I'm like, yeah, it's kind of scary because it can chew in your face, but like Cryodracon can walk around the streets swallowing children whole, right? And then take
maybe
off
the next
and
one
just fly away.
Right.
Yeah, it's like, oh my god. I mean, you think about how terrifying. Imagine I get asked like what kind of sounds they would make, and people assume they make kind of bird-like sounds. They probably didn't, because birds actually have a special sound-making structure called a syrinx that these things didn't have. So those weird metallic noises and chirps stuff that birds do, it'd be more like growls. It sound like a flying alligator. Like like the guttural growls and stuff that alligators could do. It'd be like that, or
that'd even make it
or even
worse.
mammalian sounds because they would have a larynx like us. So these things might be able to like roar and growl and things like that, or they could do things that like modern storks will bill clack. So they take the jaws and slap them together. Can you imagine a 9-foot long jaw, toothless stork-like jaw being slapped together?
Echo through the valley, you know?
Yeah, it'd be like an explosion here. Imagine you come across a pair of these things on the ground, like defending their nest, and they're pissed at you, or a flock of them, and they're just smacking their jaws together, and you're like deaf. You can't even hear. You're like stunned. The things are just walking towards you.
Oh my god!
It can look in look in a second story window, and it's just walking towards you.
Yeah, it'd be looking right through this window right now.
Yeah, it just. Hey,
I want to ask you one more crazy question. Question. I do, in this world, we do come across crypto people, and we often hear of legendary things like in El Paso or in Australia, where people say they see these giant birds that they seem reminiscent of a pterosaur. What do you think they're seeing?
I don't want to speculate too much because
But it's not a pterosaur.
It's not a pterosaur. Right. No, it's not going to be a pterosaur. If they were still around, I mean, these are big, really weird looking. They'd be conspicuous creatures. Like they're the kind of thing we're good at finding. Like if someone says, "Hey, I think I found a new insect that no one's seen before. I found a new deep sea fish that no one's seen before."
Sure you did.
I mean, yeah, you probably did. Yeah, more than likely, actually, the statistics are in your favor.
Right.
But you remember these things would have to survive as a population. Like you can't, like how old is the last of its kind now?
Right,
Like people have been seeing it for 200 years. Like wow. So I don't. But at the same time, I don't want to. I'm not going to get on here and tell people that that they didn't see something unusual or tell them what they saw, because I wasn't there and I haven't seen it and I haven't talked to them about it firsthand, and they may have seen something really wacky. We do discover new bird species, especially in the tropics, with some frequency. Not super often, not as often as we find new amphibians and insects and fish, but occasionally. So
what about
who knows
with like dinosaurs and then pterosaurs? How often do you find new species? Because it has to be fairly rare.
It's fairly rare, but not that rare. We probably get about 3 new species of pterosaurs described a year.
Really?
On average.
Oh, specifically pterosaurs. I think Tony was asking just dinosaurs.
And if you go to dinosaurs, it's probably a couple dozen a year.
Wow.
That's more than I thought they would.
I had no idea. Right?
There were 6 new species of horned dinosaur described last year alone.
Wow.
Yeah, but again, these sometimes barely different. Like, you and I would look at two different alligators and think
Right,
they're the same.
right.
And some guy would come in here and go, oh, they're not even close. That's a...
Right. Yeah. So in terms of finding something that's really drastically different, like a whole new, like, holy crap, what the hell is that?
Right.
That's more rare. Right. And I also have to give full disclosure here. You'll notice that I use the word described because, so I'm talking about the papers because that's how we're counting them.
Right,
But
right.
Sometimes they were discovered that year. Sometimes they were discovered in the 60s and 70s
Right.
and finally got around to being described as a species. So the rate of discovery is actually much harder to determine. And then you can get and of course you can get weird things too. I mean, some of the grandest discoveries aren't necessarily new species, or you don't know they're new species or whatever, but you've still discovered something interesting. I've got a field crew that goes out to New Mexico, northwestern New Mexico
That'd be
each
so much
summer,
fun.
and I got a great team. And we have been excavating, among other things, 2 of the largest land animals of all time out there. One of our specimens may actually be the largest individual animal of any
Really?
time period known from North America. Just flat out the biggest critter today.
It's like a brontosaurus looking kind of thing.
Yeah, it's like a brontosaurus looking like thing, but it would dwarf brontosaurus. I mean, it would just dwarf it.
That's just amazing that they got that big.
Yeah,
I mean,
it would.
Jesus.
I mean, no contest. They're called, the group are called Titanosaurs. They have Titan in the name for a reason.
Right.
There's only one North American Titanosaur that's described. It's this thing called Alamosaurus, and great name. And so everything that's ever been found in North America of this group, they always call it Alamosaurus. And so we've been tentatively saying that we have 2 Alamosaurus specimens, but actually looking at it, I don't think they're the same thing as one another, or they might not be the same thing as one another, and I don't think they're necessarily the same things that's been described before. It turns out the stuff that's been described before may not be the same thing as each other either. So sometimes what happens is you go back and you look at something that's been called one species before, and it's actually multiple species, which might be happening with our giant dinosaurs.
You're going to have to start learning that now. Now that you did this pterosaur, you're going to have to start getting into this field of naming new stuff.
Yeah, I might have to get into the field. Well, I'm getting to the field now of these super giant dinosaurs, the Titanosaurs. And I've been doing some blood flow estimation work, like kind of figure out like how cardiovascular system would work in something this big with a stupid long neck on it. I mean, they're just impossibly big.
Right.
They're whale-sized animals walking around, like big whale-sized animals walking around, 70 tons, 100 feet long. And it's funny. One of the first questions I always get when I talk about that side of the stuff. Someone will ask, well, who would win in a fight, Tyrannosaurus Rex or this Titanosaur? And I'm like, I hate to tell you this, but we don't call that a fight. That's called a homicide, right? Like that's just a massacre. Like there'd be bits of Tyrannosaur raining from the sky, and they're like,
That's hilarious.
"What?" And I'm like, "Well, think about it this way:
The
like
tail.
the tail on it, or the neck, or any part of it. I mean, they're like, look, they'll be like, well, but Tyrannosaurs have big teeth. I'm like, okay, look at it this way: imagine I hit you with a hammer in the head, and the hammer weighs as much as your entire body. That's what it's like if any small part of this Titanosaur connects with the Tyrannosaur. Like it just has to connect with anything at all. It's not a fight. It's like, which would win in a fight, me or a heavy hauler freight truck, right? Like which wins in a fight, me or a semi?
Right.
It's
right.
like,
The next Jurassic Park movie, if they did your 2 dinosaurs as realistically as they were, would blow away everything that we've seen already.
yeah.
Right?
Yeah.
A Titan thing?
Yeah.
And this kind of pterosaur? That would be amazing.
That'd be very, very cool. Yeah. I work on.
And
work
you
on
do the
some
design. Why don't you? There
massive
you
creatures.
go.
Yeah, there we go. I'll happily. In fact, it was fun. I was just at a design art and design conference, animators and artists conference this past weekend, and one of the people I was chatting with for a little bit was Crash McCreary, who was the original concept artist for the original Jurassic Park.
Oh,
Very
wow.
cool.
Yeah.
Well, unfortunately, our time is up, but
No worries.
this has been so fun. I really enjoyed having you come in studio. I mean, like you said, we don't get it often, but this was a pleasure to have you.
Oh, thank you very much. It was a pleasure to chat. It was a lot of fun to come on out. I appreciate you having me on here. And
When's your book come out?
I appreciate you letting me do some tangents in there. Yeah, the book is due out. Should be about March of 2020.
Great.
It might be a little flex on that, but that's
Flying
where
Monsters.
Flying Monsters. Yep, and we've got real and fancy creatures in there. So we've got birds and fossil birds and weird feather things that weren't quite birds, and we've got pterosaurs in there and bats, and then we do all kinds of crazy things. We've done a re-envisioning of the Dracula legend.
Oh, wow.
Where we blend a bat and a pterosaur, so you have this giant bat
my
monster
God.
that could actually fly at huge sizes. We just demoed that at Lightbox this last weekend. We've got a flying horse-like creature, hippogriff, that could actually fly because it's blended with pterosaur. We're doing a re-envisioning of dragons, so we'll have our take on dragon, all kinds of cool stuff in there.
Fun
Awesome.
stuff. Now, if people, where do they find more information about you? Because I know a lot of people in the chat room have been wanting to know, more information about. Do you have a website, or people?
Sure. Well, I've got a fairly boring website. I have a profile site through my university, through the University of Southern California, which they can look up there. But there's not that much on it. Probably more what they're looking for is kind of the fun side conversations and stuff. And so I have 2 social media accounts where I tend to talk about this stuff.
Give those out.
So one of them is a Twitter account, and the handle on that is AeroEvo, AeroEvo for aerial evolution, because I study the evolution of aerial creatures, and I have an Instagram account where I post some cool museum photos and stuff like that from time to time. And that handle is an old college nickname, which is Habibinator. Play on my last name.
I don't even want to go there. That's a whole story.
We are out of time, Tony.
That's a whole different story. I will tell you, there was also a joke. There was a term amongst certain folks at University of Virginia where I went to school called the Habibinator effect, and I'm not going to tell you on air what the Habibinator effect is. But
as soon as we go off air, we'll record it and send it out later.
There we go. Fair enough. Yeah. Good man.
All right. Well, thank you guys always in the chat room. Thank you guys for participating and joining us. Please share this. And we here at Truth Be Told, we love to discover new things and get the truth out there and hear directly from the people that are touching the ground. So thank you so much.
Awesome. Thanks very much.
And please subscribe. Listen to our podcast. Subscribe to our YouTube channel. We appreciate you. Until next time, I'm Tony Sweet and Captain Ron for Truth Be Told.